So when we solve things with exponential and logarithmic equations, one appealing thing about it is it makes exponentials linear. I mean, we didn't have to do this in this first example because the bases were equal. 2 to the x equals 16, 16 is 2 to the fourth, so x equals 4. But when we're solving something like 2 to the x equals 10, you know, there's a problem. We can't really make the bases equal. So that's what the power of the logarithm is. So when we take the log of both sides, what we can then do is use our exponential properties or our exponent property of logarithms and bring this down here, which changes basically an exponential like 2 to the x to now a linear equation. Because now log 2 is a number, so it's a number times x equals another number. If we divide both sides by log 2, we'll get our answer for x, and I think if I go to my calculator, I'm going to get like about 3.3231 and a whole bunch of other numbers. So let's call it to 3 sig figs, 3.32. Things like that, not too bad. So we can solve these equations as well. What I'll do is, just to save a little bit of time and not make this a 29-minute video, I'm going to tell you some of the answers to at least 2 of them. Like this first one here, we should get that x is about 1.46. See if you can solve that by taking the log of both sides. You got to do some arithmetic here to solve this equation, and I think we're going to get that x is about equal to like 0.353 or so to 3 significant figures. And you know what, I think there's a rounding error in that. I think it's like 3.54. Let's take a look at this last one though and solve this one together, because this is kind of neat. There's an e, there's a 4. It's kind of crazy going. So why don't we take the log of both sides, and because we're having the base e, I'll take the natural log of both sides. So what I'm going to do is I'm going to get like the natural log of e to the x plus 5 is equal to the natural log of 4 to the 1 minus x power. And you might remember that one of your properties, after we bring down that exponent, we get x plus 5 multiplied by the natural log of e, and then 1 minus x times the natural log of 4. The natural log of e is just equal to 1. So on my left side, I get x plus 5. On my right side, I get 1 minus x times the natural log of 4. Now maybe what I'm thinking about doing here is I got to get my x's on the same side. So I got to do my distributive property over there. So 1 times natural log 4 is natural log 4. And then I distribute it to the x as well. So now let's get all our x's on one side. Let's get all our numbers on the other side. So I'm going to add this x times ln 4 to both sides. And I'll subtract 5 from both sides. And for right now, because they're in some logarithmic forms, I'm going to leave them in their log form. So over here I get x plus x ln 4. And over here I get ln 4 minus 5. The right side is just a number. I can combine the left side by doing a little bit of factoring. And I get it to x times 1 plus ln 4. And now notice that I've isolated x. So when I divide here, I'll divide everything by 1 plus natural log 4. And the answer I'm going to get is the natural log of 4 subtract 5. 4, there we go. Divided by 1 plus the natural log of 4. And when you go to your calculator and figure this out, you should get that about x is approximately like negative 1.5143. So to 3 sig figs, what if we say that it's negative 1.51? Maybe that will be a nice answer there. So if we keep going a little bit more, we'll use some properties of exponentials and logarithms here. Why don't you tackle the ones on the left and the right? Try these two. Pause the video a minute. See what's happening. I'm going to go get a cup of coffee. If thought I really wanted to get a cup of coffee, didn't you? Well, let's take some logs. So if I'm going to take the log of both sides, and you can do log, you can do natural log, it doesn't really matter. I'm going to do the natural log of 2 times 3 to the x. Take the natural log of this side, 5 times 2 to the x. Now check this out. I'm going to do some expansion of my logarithms. I'm multiplying 2 values together and taking their natural log. So this is the same as doing the natural log of 2 plus the natural log of 3 to the x. And I'm even going to go one step further. Let's bring that exponent down and do x times natural log 3. And on the right side, we'll do the same thing. We're going to get the natural log of 5 plus, and you guessed I'm going to bring that x down, x times the natural log of 2. Now we're just regrouping some terms together. Let's get all our x's to one side. I'll move the x ln 2 to the left. I'll move the ln 2 to the right. And we're going to get x ln 3 minus x ln 2 equals ln 5 minus ln 2. Again, a little factoring on the left side. And then let's do some division. So we'll get natural log 5 minus natural log 2 all over natural log 3 minus natural log 2. Now it's a calculator expression. You type it into your calculator, you see what you get, and you should get that x is about 2.2598 and so on. So what if we say it's like 2.26? We'll go to 3 sig figs. And I know what you're saying. You look at that one on the right and you're like, no! But I'm looking at this and this almost like kind of looks quadratic. And actually, if I take this first term, it's not that, it's e. If I take this e to the 2x, what if I write it as e to the x squared? Because now check out what I have. I have e to the x squared minus 3 e to the x plus 2. Doesn't that look a lot like the quadratic equation x squared minus 3x plus 2 equals 0? Yeah, so let's solve it by factor. Let's get rid of that. There we go. So solving it by factoring looks like I'm going to get an e to the x minus 2 times e to the x minus 1. That's what it factors to. Pretty cool. So this gives me e to the x minus 2 equals 0, or e to the x is 2. Likewise, I get e to the x equals 1. All right, let's talk about solving some of these. If you want to start on the left side, maybe we take the log of both sides. X times ln e equals ln 2. But you know the natural log of e is 1. So this becomes x equals ln 2. And over on the right side, we get e to the x equals 1. Well, you also know that anything to the 0 power is 1. So that's my answer. X equals 0 and x equals natural log 2. Neat things. Boy, you never thought we'd dive in that deep with logarithms, huh? But wait, there's more. Boy, this equation is crazy. Because you've got 2 different bases going on. Oh my goodness. So the first thing we need to do here is, let's see if we can create a little bit of room. Ah, there we go. We can move that up a little bit. The first thing we need to do is we need to get the bases the same. So that's why I told you, here's a suggestion, change your base. So maybe I'll start with one on the left side and I'll change the base. You remember that change of base formula? That if I want to change this thing, I want to get it from a base of 4 to a base of 2. So it's the log of 4x plus 6 in base 2 divided by the log of 4 in base 2. Now you might be saying, boy, that made it a lot more complicated. But let's take a look at that denominator for a minute. Okay? If I want to know what the log of 4 in base 2 is, isn't that just 2 to the something power equals 4? So in this case, the value of my denominator is just 2. So it's the log of 4x plus 6 in base 2, all divided by 2. And now you're saying, all right. But remember, all this means is that I'm taking this logarithm, the log of 4x plus 6 in base 2, and I'm multiplying it by 1/2. And now we're getting somewhere creative. Because now I have a 1/2, which I know is my exponent. So now my equation, if I pull it all together, that left side, or this term here now, becomes the log of 4x plus 6 in base 2, and I want the square root of it. And now you're like, what? But hold on. Catch a breath for a minute. First we changed the base, and we got it into base 2. Once it's in base 2, man, we're home free. Because now look what I got. I got the log of the square root of 4x plus 6 in base 2 equals the log of 2x minus 1 in base 2. Our bases are the same. The logarithms are gone. So now I just have the square root of 4x plus 6 equals 2x minus 1. Is that an equation you can solve? Oh, yeah. You want me to wait a minute and let you solve it? Go ahead. I got to tie my shoe. All right, my shoe is tied. How do you get rid of the square root? We square both sides. So I'm going to get 4x plus 6 equals the square of 2x minus 2, 2x minus 1. And if I square that, remember your binomial expansion? Oh boy, that came in handy. Cool beans. Set equal to 0 and factor it. Let's see, we get a 4x squared. If I subtract my 4x, I get a negative 8x. And if I subtract over the 6, negative 1 minus 6 is negative 5. Oh, it's got to be one of those factoring problems. That's crazy. Oh, it's not going to be too bad. Let's think about it. I think 4x squared, we can factor that to 2x times 2x. And if I want to get a negative 5 again, I know I need like a 5 and a 1 somewhere. Let's put a 5 and a 1 there. And I need a negative 8x, so that negative 5 makes a negative 10x. That makes a positive 2x, and I just did my factoring. This is cool. So 2x plus 1 equals 0, so x equals negative 1/2. And I get 2x minus 5 equals 0, so x equals 5 over 2. Oh, but hold on, I got to check to see if I got any domain errors. Let's take a look all the way back at the beginning. If I go to the beginning, if I plug in negative 1/2, oh boy, I think I'm in trouble. If I plug in a negative 1/2, I'm going to get a domain error. Oh boy, if I plug in negative 1/2, like right here, 2 times negative 1/2 is negative 1, minus 1 is negative 2. That's a problem. My negative 1/2 is a domain error. No good there. That's my domain error. Bad stuff. 5 over 2 works though? Let's check. If I plug in 5 over 2, for both sides I'm going to get positive values. Oh, that's nice. So my answer is just x equals 5 over 2. Boy, look at this. We had to change the base to get the bases the same. And once the bases were the same, then we could solve our equation. Wow. You must be good to get this far. Well done.